To begin with here, we're going to take a look at a contextualized example that will help us understand the relevance of linear inequalities that we're going to be examining in this section. So in basketball, we know that there are field goals that you can score that could be worth 2 points or 3 points, depending on whether you're within the field goal line or outside of that. So what we're going to try to do here is we're going to try to write a mathematical model that can represent all of the possible different combinations of 2-point and 3-point field goals that a player could make within a game to score at least 24 points in a game. So since we're trying to look at the number of 2-pointers as well as the number of 3-pointers, and we know that the number of 2-point shots could be a different number than the number of 3-point shots, we really have two different variables going on with those then. So let's pick some variables to represent those. So I'm going to choose and select X to represent the number of 2-point field goals, and then I'll pick another variable, say Y, to represent the number of 3-point field goals that we could score within that particular game. So if we're to write a model for scoring at least 24 points, then clearly we want to take X, which is really the number of 2-point field goals, and then multiply it by 2, since each field goal is worth 2 points. That's going to give us the collective total of 2-point scoring there. And then we'll add that, of course, with 3 times Y, and then that's going to be the total number of points. And we want that to come out to be 24. Now, since it says that we want to have at least 24 points in a game, then this sign right here doesn't quite match up, because that would be exactly 24 points. So if we really want that to match up, we really want it to be that we get at least, so greater than or equal to, and then those signs there are going to match up with each other. So what we haven't really done so far is we haven't graphed it where there's an inequality. We've graphed it where there's an equality, but it's really no different. So, like, if we were to graph this, it'd be easiest if we solved this for y, because this is a linear equation. So we would have that 3y is greater than or equal to negative 2x plus 24. Note that I didn't have to change the symbol there, because all I did was subtract, and you only flip the symbol if you multiply or divide by a negative. And then we're going to have to divide by 3, which you don't have to flip the symbol there either, because you're just dividing by a positive. So you end up getting this equation right here. Y is greater than or equal to negative 2/3 x plus 8. So you can graph this like per norma, like you would graph a linear equation, because it's just an mx plus v form. So start at 8, and then you've got the slope of negative 2/3. So it gives us this line right here. So this line is going to make sense in a lot of ways, because if I pick any ordered pair on the line, it's going to satisfy the model that we came up with. So like this ordered pair, for example, 3, 6, really what that means is the x coordinate, right, is the number of 2-point shots, and this right here is the number of 3-point shots. So if you put that into the model, you can see that right there, well, you just get 6 points plus 18 points, and that's going to give you exactly 24, right? And same thing for any of these other points. So like right here, if you made 12 2-pointers and no 3-pointers, then 12 times 2 is you made 24 points, right? So what we're really interested in, though, is not just making exactly 24 points, it's the fact that we want to make at least, right? So it turns out that when we solve this for y, that graphically any points above the line are also going to satisfy what we're looking for. So like, for example, I don't know, like right there, we've got 3, 11. So if you made 3 2-pointers and 11 3-pointers, then you'd have 6 plus 33, which is 39 points, and clearly that's going to be above. So it's not only just that point, it's also this point, and this point, and this point, this point, this point, this point, this point, this point. There's an infinite number of points where you're going to have a combination of 2-pointers and 3-pointers that's going to give you at least 24 points. So to better represent that, rather than just making a bunch of dots, because you're never going to have enough time in your life to draw all those dots, we can just kind of shade all of this, and then that's going to represent this linear inequality in this particular case. Note that this shading, like, it goes on forever. Like, it's going to keep going that way and that way and that way, right? So that's going to represent the set of all possibilities. Now, not all of those are going to necessarily make sense, I guess, because like right there, that blue dot that I just made, like you would have a negative 3x coordinate, and you're not going to make negative 3 2-pointers, right? So really it's just kind of like where I've kind of made this blue border, and you can't go negative y there either. So it's kind of in that blue region, this lighter blue that really be restricted to that. We'll kind of get into that more later on.